Okay, good morning all. Intended lecture for today was on critical issues facing the Internet of Things, and if I've got time I'll make a start on that. It's not actually required for the assignments, it's just part of the syllabus to cover, and we've got one more week next week. Still hoping to get a guest lecturer in, but he's a guy that I work with on a lot of IoT commercial applications. He's not actually confirmed that he can be here yet, so I've got a backup lecture on that. Well, a sort of more interesting lecture perhaps on ambient IoT and what we call enchanted objects. So there's a backup plan for next week's lecture. Again, not to do with the assignment, just hopefully something that you'll find interesting. Today, though, quite a few questions cropping up. The assignment, as you know, is due in on Friday, and there's been a few rises in attendance at the labs yesterday. If anybody was in there saw that it was really packed out. Means it's quite difficult for us to get round everybody. So I hope you can sort of bear with some of the things there, and I'll have a few things to say about it. And one or two final sort of issues about how you might approach the last parts of your assignment. I don't want to talk too much about coding today. That should be, with any luck, should be in the sort of drop-off point. I'll have more to say maybe on the task 3, which I'm receiving quite a few common questions about that I hope to address for it. I have put a bit of extra information up just today. It's in the week beginning 1st of October. There's that last one there about Evo Home, because it's definitely of relevance to task 3. You'll find that if you understand how these particular controllers work, it's almost exactly how you'll do task 3. It's very, very, very similar to it. So I've created a folder there with a couple of documents in that might be of use, some PDF files of what spec sheets for these radiator nodes that I just want to work over. But I brought together just a few final issues about this, as I say, that may help you with, hopefully help you with your task 3 in particular, but the assignments overall. Cropping up from one or two comments that, say, a few people have said, so trying to share the joy, if you like. I had a comment, or two comments at least today, about one of the mentions in the assignment spec is about code quality. And basically the question was saying, if my program doesn't do everything that I want it to do, is that good? I understand that might be sort of bad code quality. And I sort of was pointing out that actually there's a difference between code quality and functional quality to it. Code quality is down to what good software engineering techniques you're using, about how maintainable is your code for that. Is it easy to update? A range of sort of software engineering concepts. Is it generic? for it? Have you got multiple bits of code that may well be working fine, but they're scattered throughout and you should really perhaps be refactoring? These are sort of general good software engineering techniques that we're hoping that you're employing. Now, yes, there's sort of 5 marks allocated for you using good techniques. Now, that's different to functional quality, which is to do with the actual task that you're doing. Have you actually done it well to it? Is it adequate? Is it good? Is it great? Or doesn't it actually do the sort of job? And I mentioned in one of the emails going out this week, we don't want to make adequate programs out of you. You know, nobody likes being called adequate to it. It's sort of a death by under-complimenting or something like that. A task can be working. It might well send a message from, say, the reader to the lock, and the lock moves. And you can sort of turn around and say, well, I've got the lock moving to it. To give you an analogy, if I said I want an entrance building into this room to sort of doing it, you could get out a sledgehammer and start just bashing your way through the wall, make a big hole underneath that clock, sort of crawl space to get through and say, right, well, you can get into it, you can crawl into that room, you can fit yourself through that sort of wall there, and yeah, I'll perform the task. It does what it says it does. So I can get into the room to it. I said to us, I was reminded of this the other night watching, anybody ever seen the Green Mile film? You have to execute somebody, and the fellow dies a horrible death because of some maltreatment by a prison guard. And there's this sort of great line at the end, you know, and somebody, the warden comes along and says, how can that be described as a successful execution? And the fellow says, well, he's dead, sort of thing. Doesn't, you know, yeah, he actually was dead in this sort of thing, but it's how he got dead, You know, it's how you've done that sort of task, doing the task to a greater or lesser degree. Not just does it work well to it. Now that's not to say that, okay, if you've got this, say, door opening, and it doesn't do it brilliantly, but you've done other things, that you're not going to get a higher mark. It's just, you know, that we're looking at how well that particular thing has been done. For example, if it opens one door, that's working, but really, you know, does it only ever open one door? How functional is it? So it's really the difference there between functional quality, which is doing the task. How well does it do the task? As opposed to sort of code quality. How good is your sort of coding style to it overall? What type of program are you going to be? Right? Are you actually sort of thinking of these techniques like generic code, you know, your code's maintainable, it's easy to update, it's scalable, and those sorts of things. They sort of work well together. Right? If you do use good SE techniques, it tends to mean that your functional quality will improve as well. But try to sort of differentiate between the two. Because looking forward, when I'm going to take sort of 3 academic weeks to get this sort of thing marked, and you'll get your code back, and it may get people saying, well, mine works and his works, why has he got 10 more marks than me to it? Theirs works better, basically, is a thing for it. So just bear that sort of thing in mind when you're putting them together. Really to do with task 3, this one. I've been giving formative feedback to sort of quite a few people, and a bit more on that in a second in terms of time available to do that. The node design for this task 3, the overall design, and I know it's easy for me to say, but it's actually simpler than many people are trying to put into this sort of thing. A lot of people are maybe overthinking some of this idea to it. I could say maybe perhaps some aren't even thinking at all, but that's the other sort of extreme to it. It is extremely similar to the diagram that there was issued with design to do with radiator controllers. It's basically the same, in fact. That radiator controller is the same sort of thing as a sprinkler to to sort of do it. To remind you what one of these things looks like, just got one at the front, and again I'll pass it round for viewing. We've got some specs for these radiator controls, and I've taken this one apart to show you what's inside. These things, I'll just put it on the document projector in a second. These things sit on top of a water pipe going around your house. That's what your central heating consists of. You basically got a hot water pipe going around your house, and this sits on top of a valve and then opens the valve to let the water go through the radiator or not. Good. And inside, some of the things we've got, just to again sort of remind you what one of those things looks like. We've got this radiator controller for it, and there's some pointers to it. I'll just bring it up in a moment for the sort of PDF things. This is the bit that goes on your actual sort of radiator. Their little sort of tiny pin to let the valve open and shut. And you can see there's a little cog inside that when this is on, you can turn and basically open the valve to do it. And there's a manual switch on top of it to sort of control it again. Now, I don't know how much you can sort of see inside there, but basically we've got a motor here. That thing's the motor that's turning for it, so that's sort of directly connected to this one at the bottom to sort of open it. We've got a controller board inside. That's like the processor that you sort of got, and there'll be a sensor somewhere in that. I don't know the exact sort of thing there. I think it may even be this big what's called a bimetallic strip on the side. But basically, we've got a sensor to detect the room temperature to send messages back to the central server as to whether or not the central node as to whether or not to turn this thing off for it. It's got a battery compartment at the back to work with. Now that takes 2 AA batteries. The whole thing works off 3 volts to sort of get it. And I'm looking at some of these ideas coming in, and I'll give you some sort of feedback with it. But in many cases, the proposals are for things like they've come to a Rolls Royce to drive this. That they're really sort of over-speccing what's needed in one of these. That processor has so little to do. It's got nothing to do really at all. All it's got to do is tell the motor to turn one way or the other. Really, it's like it's exactly like you're doing in task 1. You've got that servo controller in task 1. And what does that do? It listens to a message coming in, and then it says, if that message says turn on, then turn the motor. And it does. I mean, that's functionally probably about sort of 8 to 10 lines of code that you sort of got in there. Yes, there's a little library of code from the fidget motor that actually does do the motor turning for it. And similarly, there's a sensor in there that's detecting the temperature and then sending that out to this sort of centralised one. Now that is essentially what one of these sprinklers does. It listens to a command to open the motor, and it's connected to a water supply, just like this is. This is already connected to the sort of copper tubing or plastic tubing going around your house to sort of turn on. So they're both water regulators in some way. They both sort of just open up a valve or shut it. They've both got some sort of sensor in that to send back information about maybe when they should turn on or sort of turn on to it. So this fulfills all the functions of what a node should be. It's got a processor, it's got this power supply, it's got some actuators and sensors built into it. We need to think, I've not sort of talked too much about the comms to it, but this does communicate with a central node to sort of work in it. Now again, I'll just pass this round to sort of have a look, and then you can sort of get a feel for it. These things cost commercially round about the sort of £35–40 mark, and that's after the seller has done their markup on it. Whatever people sell them for, you can bet they're paying half that price at least. You know, they generally make 100% profit on everything they sell. And then and out of that, then the actual manufacturer has got to build them and sell them at a profit to the retailer. So the actual cost of this is probably about a quarter what it costs in the shops. If that, even it may be sort of even different from that. As it comes round, take a look inside what's in one. And the reason I'm sort of going over that is that's your solution to it. That's a solution. I mean, yes, it controls radiator valves and the like, but hopefully, you can sort of get exactly the same concepts in your own one. So, take a look at a sort of similar approach, and the sort of code that's going on is what you're doing in task 1 and 2. It's not that new to it. It's not the stuff available. So take a look at what you're doing in task 1. Take a look at the sort of radiator valve control, the original node layout that I suggested for task 3. And people have been sort of taking a look at that. Where I sort of did this hand-drawn idea about having these sprinklers dotted around. By the way, that wasn't to say that you have to have 4 sprinklers in your system, sort of thing. A lot of people have sort of, well, not a lot of people, but some people have come along and said, oh, well, this has got to be 4 sprinklers. I was just bringing together a sample sort of idea. The general idea being that an individual sprinkler node would look something like that thing that I'm just passing round for it to have a look at. Oh, that's just there. So the individual sprinkler nodes have got those sort of things in. They've got that motorised valve. They've got the processor in there. They've got some sort of sensor in there. They've got some way of communicating to the sort of outside world. Now, as I say, that particular Evo Home one, the radiator valve controller, so similar to that. That's got almost exactly the same node layout to sort of get there. And it also communicates with a centralised hub node. The assignment spec gave you a view of what the Evo Home system looks like and who communicates with who with. But how the hub node, the thing that's controlling them, that's the thing that does, just talk to the individuals. The individual nodes being wireless controlled. Hopefully people are getting that you can't really run Ethernet cable out to these sprinkler systems, just like you can't really run Ethernet cable out to your radiator controllers perhaps in every room. You can't run wired connections for electricity out to all your radiators in it. That particular Evo Home one, run by 3 volts, 2 AA batteries, and they typically last about 18 months, 2 years. So to sort of work with, depending on how often they open every day. Yes, if these motors were continuously opening and closing 24 hours a day, then it would sap the battery. But they're not. They're opening up. Maybe a sprinkler might sort of turn itself on, depending on the sort of piece of the day. It might only go on once or twice a day, and that's just to open the motor and then close it again later on. So how many times can something open and close a motor before it sort of runs out of power, if you like? I think probably everybody at some point in their life may have played with some sort of toy in your early years that runs off batteries. Whether it's a train that runs along or a car or something like that you can control. And they work off standard batteries. They don't have to have some sort of power pack like you charge up your phones with. It's a bit of overkill, basically. So what I'm sort of saying there is like you're maybe sort of specifying some things, but it can be, if you're not careful, a bit sort of too much for it. You don't necessarily need, like you have for your phone, one of those external power packs that supply however many volts it is to your phone, and it's probably sort of quite big. And they're rechargeable, and you've got all sorts of, so many milliamps of power and stuff like that in it. Think about if it will work with batteries, that's the easiest thing for it to work with. You may want to sort of, some people, perhaps have put sort of a solar power thing on this. It's got a sort of tiny little cap, maybe on top of the dome of the sprinkler to sort of charge it to help the battery life. That could be sort of useful to it. They all add maybe to the cost of this. But I mean, it doesn't really matter in some ways what cost you come out with, as long as you're not coming out with several £100 for a node. That's a bit sort of unrealistic that people would progress down that sort of route. And that probably means that you'd put too many expensive components in that to sort of work with. Now, we're not expecting you to be electronic engineers and know how to wire these things together. Just, is this a feasible suggestion that you're doing, that you're working on? So yeah, I've looked at the demo of those things, and I will just sort of quickly go on to a bit about sort of task 3 still. It may be that you need a sub-diagram to show what's in that node. It gets too big a diagram to put out, but you are expected to put a bit of annotation in there according to what's in the spec. It sort of tells you what to sort of put in the spec. Show what details are actually in the node, what components are in there, and identify them. And is this sort of thing feasible? If you're proposing to put a particular processor in there and say that it's going to use Zigbee to talk to the hub node, does that processor actually do Zigbee? Does it have Zigbee built into it? Some do, some don't. And if it doesn't, you might have to get an additional component to, like you have with sort of like a plug-in dongle almost. Some of you may be old enough to remember the old laptops that didn't originally come with Wi-Fi and Bluetooth built into it. And you had to get a little USB dongle that you plugged in the side to get the wireless connection, or a Bluetooth dongle to put in the side. And they still do those for some sort of laptops. When you get a Bluetooth mouse, you get a little dongle to plug in your machine for it. That's because the original board didn't come with Wi-Fi ready built in. That was seen as an optional extra. And it could well be that the processor you're choosing doesn't come with the appropriate comms put in. So what you need to sort of spec and identify those node components, and just sort of take a look and think, well, can this actually work? Never mind about, as I say, how you wire it together. I'm not expecting that. But is it feasible that this could do the type of wireless comms that I want it to do for it? If it was, or does it need an extra plug-in for it? Is it feasible that these particular components would run off a 3-volt battery? And if you've got a 9-volt motor, probably not. And again, not expecting you to be electronic engineers, but to have some sort of common sense about it. Like, if you've got a toy and it says, and there's room for 4 batteries in it, and you try and run it with 1, it's just not going to work, sort of thing. And as I say, that boils down in some ways to sort of common sense. So, is it really sort of feasible? That's for the sort of node design, and the messages really. That's another one of the things that's asked for in the spec. When the individual node is talking to that hub node for it, and just go back to the diagram. So when you've got these individual nodes talking to the hub node, what are they saying? What messages are going backwards and forwards? Now, you've done that in task 1. You've been doing that in the sort of labs where you've got some sort of actuator, like a servo, talking to the server. It's sending a message to and from to it, or maybe into sort of Node. And what's contained in those messages? If you're talking about, say, if it was an RFID reader, yes, it's sending off a little package with the RFID tag that it's read, perhaps the reader address, a couple of other details maybe, but you've got a little package of data that's going off to the hub node, and you wrap that up in JSON for some reason that I told you. So it's to do with, well, what's being exchanged between it? What is the node likely to send to the hub node, and what is the hub node likely to send back to the node, or in the sort of first place? I'm not after you saying, well, this will be a Boolean thing, and this one will be an int, and it'll do exactly this data structure. But supposedly, these nodes sending back some sensor information, or the hub sending out a message telling it to turn on and to identify a particular one for it. And what, if any, data wrapper may they have in there? If they may not do, but that's sort of the thing that's mentioned in the spec about looking what those messages are going through. And as I say, it's very similar to what relate it back to task 1. It's an integrated assignment. There's a lot of similarity at all sort of levels to it. That last one there about the wireless comms, what type and is it feasible, depending on how you decide that the node what wireless communication method they should use, for it, whether it's Wi-Fi or Bluetooth or Zigbee or Z-Wave or whatever. That depends on then whether or not your processor can actually do that for it. And I've mentioned already this idea of the power supply. Fine, if you want to suggest using some 12-volt car battery to do it, it was one guy keeps sort of joking with me, it's unrealistic to say that because it's working off 12 volts, you're going to put a car battery next to each one. It's not really, again, a sort of feasible solution. That's the equivalent of bashing a hole through the wall and a crawl space coming through and calling it a door entrance to it. Yes, it works, but it's not really sort of feasible for it. Just for your power supply, just ensure the node can be powered by that. Try and think, if you can, about how long how long are these things likely to last for. That will depend on how often they're used for it. Whether or not how often your node's wanting to communicate for. Can it sort of go to sleep and then wake up to send a message and then go back to sleep again? That sort of thing was covered when we did the networks and operating systems parts in the lectures about this ability in the operating system to sleep for a bit and wake up. If you are thinking about putting the voice control part into it, many people have just sort of put on the outside a picture of a little, this is some of the feedback things that we're hearing. Perhaps you just put on the outside on the diagram picture of an Amazon Echo and draw the line to your hub node and say, right, well, that's it. Based on what we did last week for for voice control and for Amazon Echo in particular, that's not how the data flows in it. Remember that the actual device does capture your voice input and effectively is almost like an MP3. You can sort of send that voice input off to the Amazon web servers to find out what you actually said. So to take that voice file and analyse it for words, decide what the syntax is, using this sort of voice analysis, natural language recognition, and work out what you actually said, and then find out which particular skill it's working against. Is it something like Alexa, tell sprinkler to turn on, or Alexa, tell sprinkler water the garden? There's sort of key parts in that about the skill name and the verbs that you're passing to it. So there'll be AWS in the background listening to that actual voice and do the voice analysis, but then telling some web service to actually contact your home to do that actual method, to do that actual service that you want. So somewhere there would be a web service either on Amazon's cloud or somewhere for yourself, the equivalent of this server, if you like, running somewhere, that can then talk back to your hub. So think there about what we did last week there for it to expand your diagram. Finally, if you are using MQTT, you don't have to. It's not it's not a requirement of the system to use MQTT. We've used it for our task 1 and 2. You could set up direct communication between the two without it. But if you are using MQTT, we've been using like free versions of it. And like many web services, they're often free for initial use, or experimentation with, student use or something like that. But as soon as you start using them in a commercial environment, where you're charging people for your service effectively, then you might have to pay sort of commercial rates for this. So just, again, something to bear in mind for it, the sort of possible, whether or not you might set up your own MQTT server or broker on your own cloud, a manufacturer sort of cloud, or are they using a third-party one to it? Possibly thinking of what to say about that commercial usage in there. I'll come back to sort of presenting the code just in a second about how you might present your results. The thing that I was pointing you at before, I was saying in that week of the 1st, where we're talking over nodes and the like, what nodes do. There's this section on spec sheets to sort of get out. Now, just to give you an idea of what some of those are, this is here that particular Evo Home one to it, and it gives the specs there about what temperatures it can run in, how far down, what sort of stroke there, how far up and down the valve controller goes, what batteries it's working off to it. Now that's just an initial spec sheet. If you wanted to find out a bit more about, say, what wireless comms it's using, you might have to dig out a bit more looking into that one. But certainly it does use wireless comms in the background. I'm fairly sure it's Z-Wave to sort of do it. Also included just in this, just for reference, is like a blowout of what that sort of thing looks like, the sort of installation, so you know exactly what's on each one. It's only for a bit of background, really, and I don't want you to go around and think that Evo Home are the only people doing this. Loads of people are doing radiator controllers, which are effectively sprinkler controllers with another name. So you can just rejig it, repurpose it for something else. Netatmo do the same thing. It's a French company. They do a lot of environmental home products. I'm just looking over on, that's one of the Netatmo things. Perhaps they look a bit more slick. They've got some nice little glowing lights when they're sort of turning and when they're going on and the like. For it, a nice little app for it to sort of work with. And that one there, £62 for the valve. Drayton. You may not sort of be aware of, you may never have heard of them. I don't work for a radiator company, but they do a lot of radiators, basically. But that's a similar one there for it, £40. But if you sort of look down, it's very sort of similar in look. You get the app with it, they fit in the same way. They can retrofit onto valves or video of it sort of working. You might find them a bit of a spec. And in general, if you go to Amazon and look up smart radiator valves, there's that Drayton and Netatmo one. You've got ones there by Akiva, Energy, ones, different ones by the different manufacturers. Bosch doing one, Hive doing their version. So, whereas about 3 years ago, Honeywell were the only people doing it, they're flooding the market now with different sort of products coming out of it. And yes, I'm not asking you to design the radiator control valve, in some ways I am, because that's what the sprinkler thing is. So take some inspiration of what a similar product does and to what's inside it. Yeah, I mean, I know that these have come after sort of mass production that brings the sort of cost down, but these are retailing at the 40 to 60 pound sort of range. So you know you end up with something that's 800 to 900 pounds, you're probably a bit off being somewhere to what sort of your components using may be a bit too expensive. Just going back to handing in to it, I want to, where I can, avoid having to compile and run 180 pieces of software. You see how tricky it can be configuring these with your individual versions of Tomcat, individual versions of the JDK. I will be relying essentially on screen captures that you do to show me it working. So include enough to actually show that it does work for it. Because if you just sort of show me a database table or something and say, yeah, well, obviously it's in there, I don't know where that sort of thing's come from. I don't know whether or not you've just manually inserted those values in or not. So try and trace the appropriate calling or passing of messages as they're going through. So when you do, say, capture an RFID tag, just do a little print saying, I've captured this, I'm about to send it. Here's the JSON string that I'm sending. And then at the other side, when it arrives on the server should say, oh yeah, I've just received this message here, here's what it is. They're just little debug prints, and these are sort of some of the things that can help you debug your code anyway. I often sort of say to people when they're saying, can you debug this, track the message as it goes round. So whenever you're doing a remote call via a server or MQTT, let the sender say what it's sending and let the receiver say what it received. So, and that shows that the message has sort of gone through for it. And again, these sort of database tables before and after. Because if it's not there, then yeah, okay, I'll dig out your code, I'll compile it, I'll run it. I'll probably find a lot more that I shouldn't do or something. You know, depending on how paranoid you are about your code, you may want to say, well, I hope he doesn't look at this because I'm not that sort of happy with it. Yes, I'll be sort of scanning through your code. But what won't look good on you if I have to try and compile this and run it and then it doesn't run. For something goes wrong, it's missing jar files, a very sort of common one. You've got some libraries that are still stuck there on Bill Smith's documents folder inside. So make sure that your whole thing will actually run on some sort of remote one. And that's for the Android one as well. You can use prints in your Android and see those in the console for it. So help me to sort of help you and not bring over attention to yourself, you might say, in some ways. As I sort of mentioned, yeah, this is a very large class. 180 people handing in on Friday. And where I can, and I have been giving people formative feedback on what they've done. They showed me what they've done and said, yeah, okay, yeah, that looks sort of great, maybe improve it here. Perhaps sort of thinking about looking at that here. We've now got, sort of 3 days left to that. And I've given out some sort of personal interaction, some sort of feedback to some. It's unrealistic to think that I can give that amount to everybody now to it. There's just not enough time in the day yet. And some people may be appreciative of getting an answer at 10:30 at night when they sent a message and I sent a response saying that. I don't imagine I'm looking outside life, you know, that's sort of sad character. I will try and answer where I can, but you know, believe it or not, somewhere inside is I am human. So please sort of bear that in mind that I know it's important to you and I know you're under stress. You want some sort of feedback, but the bigger picture of the time sort of available. And a lot of this has already been discussed as well. A lot of what I tell or suggest to people is already out there. So there's a huge amount of issues that are being discussed and talked about on the forum. I know I keep saying this, but all those would have been emailed out to you. So and it will save you a lot of time if you can just sort of have a quick look through to see, well, has this sort of thing been mentioned, or something you might say, I'm sure you said something about this to it. And finally, this bit about the actual submission of it. Yeah, the cut-off is 11 o'clock on Friday night. Certainly, if you try and upload it at 5 to 11, you almost certainly won't be able to just because of the sheer number of people trying to do it. And it's the upload and notification can be sort of quite slow. And I get a lot of panicky emails at sort of 11:05 of people saying, I can't upload it, I've tried to, and it's not responding, you know, I'm having to wait sort of all that time. Basically, don't leave it, I know it's easier said than done, don't leave it that late to do it, because you could well just get in, it's like rush hour sort of thing. If you leave it a sensible time of day, you'll zoom through. If you sort of want to arrive at 9 o'clock and everybody else is trying to arrive at 9 o'clock, you get a big jam going in. And realistically, anything after 10, you might be having a bit of trouble actually submitting to it. So, usual thing, don't leave it too late, because the onus is on you to actually get it in there to it. So, I know at least one person submitted already. I've not sort of checked recently. Somebody submitted last week, and you know, big thumbs up there to that smug person, whoever they may be, and everybody instantly hates them. But yeah, just don't leave it a bit too late. Now, is there, and it might be difficult to say, but is there any sort of common things that either come out of that, or people got a sort of question in their mind? But if anybody's got a question, it's likely to be that it's in everybody else's mind, or several other people's mind as well. So it won't just be about sort of you. Is there something that's sort of cropped up either there, or that you feel in common about this that you feel might be benefit to anybody?
With the, for example, Amazon Web Services, how much detail do you want in terms of the diagram? Do you want us to explain?
Just the flow of the message.
Just the flow, not
just the
all
flow,
the detail that you get.
Not the sort of anything. Well, certainly nothing to do with what code he's running, because we're not expecting you to write any code for this. Perhaps what that code does, so it'll receive this and send a message back saying sort of something else, or just a description of what the code does. And yes, how it flows from, say, from your Echo device up to down to the web server, which decides what you said, and then that will invoke some web service, and then that will talk back. So like there's 4 points in that: the collection point, if you like, Amazon Web Services, the web service itself, and then your node you're going back to. So yeah, how that's going between them, what's going between them. Yeah. Anything sort of else? Okay, well, realistically, as I say, I have planned on talking about sort of current critical issues facing the Internet of Things. Wrong quarter to, I don't think I'm not going to make a start on that really, get anywhere sort of realistic for that. Good luck on getting all this thing in. As I say, keep on sending the messages through. I'll try to help you where I can. As in the labs, response rate might be a bit slow according to how many people ask the question. But please try and look at previous messages. Thank you. I'll see you soon. Hi. My friend. Register on the front here if you need it. Yeah, that's fine. Yeah, that's a how did you know which door? No, just assume that there's something up there to supply a door. So basically validate your Android ID and allocate it. Yeah, I mean, why would they have more than one? Is that just
Well, yeah, one for that, so yeah.
Yeah. Oh, right, yeah. Well, that's okay. Just put a little note to explain the
You know, for your two setups at time, are you cooking at the same time or separately?
Well, the reason I gave two is just in case I'm marking at home or in the office, so I'll unline the top two.
Oh, I see.
in at the
I thought you
same
were going
time.
to check both.
No, it's just so that realistically you don't actually have to put those sort of things in. It's just so that when I do test it, all my cards aren't instantly rejected as being not known. And what I do to that is I'd log onto your database account and push it into the table. I'd have to find the table, I'd have to work out what the other value. It would just be a bit of a ball ache to sort of do that. So it's just easier if you can pre-prepare that thing being in there.
Are you going to match the cards? Because currently the cards that we have with the tags will only work so for the first one, the first tag won't work for the second one. I mean, I can
That's something. I assume that particular tag might be assumed with that door. It's not going to be a sort of a real issue if you don't necessarily sort of configure it.
Right.
I'll be working off your screenshots. Essentially, it's only if I come to actually physically compile and test it that I need to have that sort of thing in there. And that's why I was also asking about hopefully you can just grab me direct access to your database table. Again, I couldn't log in with you and sort of get that. It just makes it easier to more quickly progress.
Where's the other list?
Grant access statement, you just run the strict SQL.
It's just grant access to your
And there's
your
nothing
schema.
else you have to do, because they
No.
ran it and it just said
Okay.
update effectively. I didn't know if it actually worked.
Yeah, it just means that if I log in as Nick
Yeah.
student, I can see your tables.
Yeah.
Basically, in what's in there. Okay.
Hi.
Yeah.
When you get the test sets,
Okay.
the tag IDs and all that, is that in your... I got to add them, I didn't see them.
Right to that one from now
I'm
on.
guessing it's just a tag ID.
That's
he has to say RFID. Like for mine, I test whether the motor matches with
Right, that'll be useful.
the door you're trying to open. So if like if the RFID and motor
I'll
connect
remember
to
what I
match,
see.
then they won't work
I
together.
guess the tag ID is a different tag ID. You can just set your own card to that door just to make sure it works.
Yeah, that's what I did.
I'm gonna actually ask him while he's could he send me his Android ID? Because then I can add that into the table. So
No, well, rather similar to what I was
set it
saying,
up.
Yeah, that
the
would
sort of RFID, even your
There's no,
well,
For mine, any app that you use with Android is just going to work because I didn't really worry about
mine was
it.
going to work, but in the database I
Oh,
stored
no,
an
not
Android
that
ID
itself,
because then
yeah,
either
yeah.
use
So you can install the Android ID, but all Android apps
And
will
hopefully
the
someone
tag is
viewing
just Android
those-
device,
those
so
apps
it's generic.
but I still
So
get
it's
it.
that
You can open any door with,
screen and
you know,
ideally
the
a
app.
scrollable list or
Some
something.
are secure, but I
Or it
didn't
might be
really
like-
care.
I changed it, I've done it differently.
Sophisticated.
The Android ID is the same, it's basically the same as
Just to draw the diagram.
Anything Word, you can do it by hand. If you like, if it's fairly neat to scan Yeah.
So I realised you're quite busy, so
Okay, no, it's
wanted
okay.
to cancel that 1 o'clock meeting today.
Okay, right,
Because,
so-
you know, I'm fairly there.
You're fairly sort of confident on it.
And I just realised you must be packed anyway.
Oh no! I mean, if people have booked a session, then
Are you su-
that's your right.
Are you sure?
Sort of thing. Yeah. I mean, I'm not going to give priority
But
to somebody else.
Is it not like a lunch hour or anything like that?
I'm
it occurred
free.
to me
I'm,
later
if you like, free. I've no teaching commitments until 4 o'clock.
Oh,
So
okay.
really, all I've got is meetings, and I'll just find a half hour when.
Yeah, okay. In that case, I'll come because
Something I can talk about.
you know, I just thought.
Yeah.
If
I mean, I
set even today.
I restrict people to about half an hour or something
Yeah,
like that.
okay.
But again, and I say there's 180 people, but realistically, I see about the same 20 people.
Right.
You know,
okay.
most people don't come, and my friend here, top of the charts. Sort of thing, yeah.
Right. Okay. That's good news in that case.
Yeah. Yeah, I mean, I'm happy to talk over again.
Okay. Right. Thank you very much.
If you like, yeah, because I thought you were going to do that yourself. Sort of, yeah. in some ways, the later you leave it, the better, because you get more chance to make changes. But the later you leave it, the less likely I am to sort of look at it. Right, I mean, well, if you upload it and you change your mind, you can always re-upload. It's a multiple submission that you can do. So feel free for that.
Do they have to be in 3 different folders or every?
No, just one zip file. One zip file for it. So long as then I can import the projects, and it's unlikely that any one particular person I will load up their files and sort of check it. As I say, for so many, I'll probably do about 20 people where I load their project. And the only other time that I'll do it is when I look at your suppose output and look at your code and think, nah, that never came from that sort of thing. If I think that people have faked their tables. Yeah, I know. That's. But luckily, you can sort of tell from the code whether or not that's sort of done.
Yeah, that's the reason why I've done loads of screenshots, so it shows that.
Yeah. I know you want to go maybe the other way, sort of. I say, well, 90 page.